Hi, my name's David, and today we're looking at the 23 most used geometry nodes in Houdini. And I think this is a great way to start learning Houdini because of the 80-20 rule. And these are some of the nodes that you'll probably be using most of the time. I got this idea from Mike Linden, who I follow online, and he's got a great blog post about how he came up with this. So these are his 23 most used nodes. And actually, if you scroll to the bottom of the page, you can find a download that will help you find your most commonly used Houdini nodes if you want to. But I thought we'd just start off today by looking at some primitives. So you should be familiar with primitives from other programs. Today we're going to look at circle, tube, line, sphere, and grid. Houdini primitives are similar to other 3D primitives, but there are some differences in them as well, which is what we're going to take a look at soon. So I'm going to turn my background image off here. And if I come up to the toolbar here and I can drag out a grid into the viewport, you'll see it's created a new grid object at the top level in my OBJ context. You should be familiar with what I'm saying right now from my other Houdini tutorial where I talk about the interface and getting started. So if you're not, go watch that first because I'm going to breeze through some of the basic stuff. So it's created a grid object. I don't want it to create a new geometry node at the top, so I'm going to go back inside my tutorial node, come up to this option here and go create in context. Now if I control click on the tool again, which creates it in the world 0, you'll see my grid object is in the same geometry node, my tutorial node, which is nice. And you'll see that we get some basic options in our parameters pane. Every primitive has, some of these options where we can move it off the center or change the scale, stuff like that. Change what plane it's on. Change, whether we only want rows, columns, triangles, just basically choosing how we're going to generate that geometry. And one of the neat things about Houdini primitives is the ability to change between NURBS, Bezier, points, and I'll explain more what they do in a second. And points, you'll see that it's not actually generating any polygons, just the points for the polygons, which you can see if I visualize it there. I'll show you what the NURBS option does. If I create a circle node and give it, say, 4, let's go 5 divisions. And then I come up to the perimeter type and change it to NURBS. You'll see that it's actually a NURBS curve. So it's interpolating smoothly between the points, which is really cool. And it's so neat to be able to just change the different primitive types on the fly for like nearly any piece of geometry. And it's also worth noting the difference between these two ones here, primitive and polygon. If you select primitive, you'll see that there's no points that you can see. Well, there is a point there. If I middle click on my circle node, you'll see there's one point, and that's because it's hiding underneath here. If I just make my my point size a bit bigger, you'll see it's there. Make it huge. So it's hiding under my little gimbal there. But there is one point. And so a primitive in Houdini is one point, and the rest of the shape is generated mathematically around it. So if you come to another primitive, you'll also see, let's do a sphere. It starts off as a polygon mesh, which means, it's got all these faces and lines and stuff that you're used to. Then if you change it to primitive, there's none of that. But again, middle clicking on the node, there's one point, and that is in the middle. And then Houdini is generating the rest. So it's important to note that there is only one point for primitives because that can have an impact on performance down the track, because it doesn't need to carry all the weight of the information about every single point. It's only the single point. All right, so a sphere is pretty easy. There's actually not that many options for a sphere. A polygon versus a polygon mesh is the main difference between them is the topology. So a polygon mesh, you can choose different ways for it to generate. Actually, that was pretty cool. Rows. Or it can generate triangles or quads. And you'll see that at the top you get this funky looking pole where all the points are meeting at the top. And you might not necessarily want that, which is why a polygon might be useful. If you put that, if I append a subdivision to that by typing in subdivide and pressing Shift Enter, which appends it and turns on the display flag, you can see we can generate a bit of a smoother mesh with the polygon option, as opposed to the polygonal mesh. You can see that doesn't look too pretty. So that's the main difference between those two options. Again, for spheres, you have NURBS and Bezier. A polygon soup is kind of similar to a primitive. I'll have to explain that more later. But basically a polygon soup is still representing that whole geometry as one point. But the way it's doing that is a bit differently because we'll leave that for another time. Again, box is fairly similar, except you also get, it's basically the same. There's not much more to cover on that. Let's have a quick look at the line. The line is it's pretty useful. You can change the length of it in the viewport by dragging this thing, or coming over here and doing the same thing. Again, you can tell it to only generate points, so it's not generating the line between the points. And that's basically it. Those are the primitives. There are a couple other types of primitives, like a metaball, which I won't go into, but they're cool. A platonic solid is also cool. Here you got like a pyramid, and if you change if you change the type, you can create a cube or octahedron or a teapot. So platonic is also cool, but that's basically primitives. I'm just going to make a little bit more space down here by clicking on this down arrow on the timeline. Just go to that. So we don't need that for now. So if I select some points on my sphere here by pressing 2 and just dragging a box around, you'll see because I've got select only visible geometry turned on, it'll only select what's around this side. Whereas if I turn that off, it'll select all of the geometry over there. So if I leave that on, select some geometry and hit delete in the viewport, you'll see there's a big hole. And in my network view, it's appended a blast node onto my sphere. There's not a lot of options in the blast node. You'll see it's got our point selection there. You can change it to primitives or edges or something like that, but that won't necessarily be that useful to you because if you've used this specific point selection, because there are different numbers, obviously. You can change it to delete non-selected, so it'll keep what you've selected, which is the handy option. If I append a delete node, you can also carry over the point selection to the delete node, and you'll see it's exactly the same. So what's the difference then? The main difference between them is the delete has a lot more options. And also I found on the forums, from a quick Google search, that the blast node is much quicker for smaller operations, like dealing, something like this, or only deleting a few points or a few primitives. You'd want to use the blast node, because it's just a stripped back version of delete node. But for anything more complex, you'll probably end up using the delete node. So if I wanted to delete, say, every even primitive on my sphere at bring out the primitive numbers, you'll see every second column has even numbers. If I wanted to delete every second column, you could put a simple expression in there at primnum modulo 2 equals 0. So we're saying if they're even, then we want to delete them. Of course, have to change that to primitives, and we've deleted every second column. You can delete by range is another handy one. So I'll have to get rid of my expression, I think. Oh, right, because that's what actually the delete by range is doing, so of course. So it's selecting one of every two primitives, which is the same as what our expression was doing. So it's deleting every other primitive. You can increase that to one of every four primitives. Now it's one of every six, it's deleting every sixth primitive. You can delete four of every six primitives, and so on. You also have an option to keep the unused points. Another useful one is bounding box. So if you have to turn off enable here on this tab, go to bounding volume, and we can say we want to delete everything inside of this bounding volume. And if I move that up, you'll see it's deleting only what's inside. And as always, you have the option for delete non-selected, so you can flip that around easily enough. Another cool option is the normals. So I can say I only want to delete up-facing polygons. So if I bring out my normals here, you'll see it's only deleting polygons with normals that are facing due north, which is x, y, z. So this is the y parameter. It's only deleting polygons within a 40-degree angle of that. So if I make it 0, it's not actually deleting any, because there's no polygons with the normal facing true up. But if I start increasing that slowly, you see it's deleted the top cap. So yeah, that's basically the delete and the fuse node. Sorry, not the fuse, that's the delete and the blast node. All right, moving on. Next is the facet. Facet's, I think, a bit of an odd one out in this group because it's I think, the only pure modeling. I mean, all of them can be used for modeling, but it's the only traditional modeling operation here. So let's have a quick look at that. So the easiest way to think of a facet, if you're coming from Cinema 4D, is to think of it as a Phong tag. So if I append a facet onto my box and to post-compute normals, it'll try and smooth out the corners of, the harsh corners. So it controls your smoothing groups, basically. I don't use it for much more than that, although it does have other options you can explore on your own. That's facet. So next up we have attribute rename, and now we're really moving into what I consider the heart of Houdini, is attributes and groups. And to explain this, I'm going to try a bit of an analogy. So bear with me, okay? So if we think of our points and our primitives as little ants, little worker ants, and there could be hundreds of them, could be thousands. We've got a whole colony of ants, okay? They all work really hard. And the ants want to feed their queen, right? So they're always carrying around bits of food. They're always bringing stuff back to their nest. And what they're carrying here on their strong little backs could be anything. Could be pieces of lettuce. It could be a little worm they found. And that's kind of analogous to how attributes work in Houdini, right? These little pieces could be anything that tells us about the ant. So if we continue, I'm probably going a bit too far over. If we continue with the analogy, this could carry information about the ant's age, who its parents are, what color it is, how tall it is, anything like that, right? So that's kind of how attributes work in Houdini. So let's do an actual example. We have our sphere and our trusty grid. In the grid, I'm just going to tell it to generate only the points. And now what I want to do is type in copy to points. Oops, copy to points. And I'm using this because we're going to hit two birds with one stone here. Copy is another commonly used node. And so the first input of the copy is the primitives to copy. So we want to copy our sphere to the target points of our grid. Then I'll display that, and you can see we've got spheres copied onto the points of our grid. I'll make our spheres a little bit smaller. Now if I put the display flag just back onto my points for a second, what if we wanted to color each of these points a random color? How would we do that? Well, we can do that with attributes, which is like our little, we're like putting a pack onto our, say we're putting a piece of lettuce onto our ant's back, okay? This is our first piece of lettuce. I can name this color with the Australian spelling, of course, because I'm Australian, or UK spelling, I guess. And I'm going to call this CD, which is the global parameter for a color. Oh, and actually I should say how I get that as well. If I type in attribute att VOP, put down something a VOP called a VOP, which we'll also be looking at soon. But I'm just going to show you how to find out these parameters, okay? So Houdini comes with some global parameters that you can use all throughout Houdini. And an easy way to remember what they are is to drop down an attribute VOP, which we're inside of now, and look at these guys. So you can see at the very top is our position vector, which is used all the time. We've got our velocity, and there's other common things. Here we've got our CD, which is, again, a vector, and that's what controls our color. So in my attribute create, I type in CD, make it a point class is fine, make it a vector, and let's say we only want to make them red. So now I have to display that, and it might be hard to see, so I'll see if I can bump the size of those points up. Scale, point marker size. Well, actually, an easy way to show it is just to highlight my copy to points, because the copy to points will automatically take on the attributes of our little ants, right? Of our points. So now you can see they're all red. Now if I wanted to give them a random color, I can go back to my attribute create and type in a little expression. We'll do rand. Now don't worry if this goes a bit over your head, I just want you to look at the visuals, okay? We'll be getting more into expressions and fancy stuff like that later on. For now, I'm just giving it a random value between 0 and 1 based on its point number. So every point has a unique point number, which means every attribute here will be random. So now we've given them a value from 0 to 1 in the red channel, and that's being copied over because of our copy to points. If I turn off copy point attributes, you'll see it's no longer copying that over, but we do want that for now. To quickly show off one of the other nodes that we had in our list is the attribute rename. And let's say I want to rename my CD attribute to something else. What else can we use? P-scale, we'll see if that works. P-scale is another one of those global attributes. Strangely enough, it's not in our little VOP here. So this one's a little bit harder to find because it's to do with particles, which is something that we'll look at later. But P-scale controls the size of each particle. So now I'm still generating a vector with a random value of 0 to 1 in its first field. Actually, I could even change this to a float because say we rename this, rename to P-scale, because a P-scale only needs a float, it doesn't need a vector. I can get rid of these as well if I want from the attribute rename, because we're only doing one. It's like the simplest rename, we're only doing 1 point rename. And because our copy to points is copying over all those attributes, it's copying the P-scale from the grid points to our spheres. And now we had very varying sizes of spheres. Diagnosing that here in Houdini, and that's with the geometry spreadsheet. I should explain what I'm doing there, shouldn't I? So I opened up the geometry spreadsheet, which I actually mentioned in the first tutorial, you might remember. And I can come up to this arrow in the top right corner and go split pane top and bottom, or alt right bracket, and that'll give me a new pane down the bottom for my geometry spreadsheet. This is how I normally organize it. I like having this guy down here. And how you use this guy is, you're not always going to be looking at every single one of these values. And in fact, you basically never do that. You usually check the minimum, maximum values of any attribute, and you can do that by toggling the sort function. It's like any other spreadsheet, sort of like an Excel spreadsheet where you can sort by different values. So we can sort it by our minimum color value, which is 0.01, which of course is getting transferred to the P-scale. So the smallest guys that we'll see will have a P-scale of 0.01, which might be this guy over here. We could tell if we turn on our point numbers. Whoa, that's a lot of points. Maybe we look for a 0.95, which is down here. So this guy here. Yeah, so he's our smallest guy, 0.95. He's the smallest ant, so to speak. Now going back to our ant analogy, that P-scale or that color or that piece of lettuce, that could be absolutely anything about that point, right? That's one of the great things about attributes is you can create your own, you can name them whatever you want, you can give them whatever values you want, and you can use them to drive anything you want. Now this little expression is great. There's actually an easier way to create random values, and that's with, especially on our attributes, that's with attribute randomize node. I probably should have shown you this straight away actually, because it's a little bit more intuitive rather than looking up some expressions when you're a beginner. We're bringing in our CD attribute. It's got 3 dimensions, and we want our minimum value of the red channel, which is the first one, to be 0. And we're going to put the others at 1, so there's no randomization happening for that one. So I'm going to disable the P-scale node as well. Of course, I have to delete my expression. Just make that 0 for default, and you'll see that in our attribute spreadsheet, we're initially creating all of the color to black. You can't really see it there, but then we're randomizing it to red and copying it 2 points. Finally, we can actually do the same thing all in one node, which is the lovely attribute wrangle. So we've got our friend the attribute wrangle here, and by default this is running over our points, which is what we want. So for every single point in our grid, it's going to perform this code. Now, we can do the same thing that we did before in our attribute create by creating a CD attribute and making it equal to a vector, which we define with curly brackets, and make that 1, 0, 0. And the curly bracket, see it's erroring out there because I hit Control Enter and it hasn't finished. And then we finish off with a semicolon, that one. While you're inside of the attribute wrangle, you can press Control Enter to accept it, or you can just click outside of the node. It's the easiest bit of code ever, right? All we're doing is creating our global CD attribute, which is our color attribute, and setting its first value to 1. Now that's getting copied over to our points, so all of our spheres are becoming automatically red. However, if I wanted to randomize it, there's something I have to do a little bit differently here, and that's to do with, hopefully I'm not getting too complex for first Vex lesson, but just hang in there for this section. I couldn't just do a randomize function inside of here. Let's just try it, okay? We'll do a rand, and again, we'll base it on our point number, pt_num, Control Enter, and that's going to error out. And that's the way because of we're initializing our vector. So initializing means just the way we're setting it up. And to fix that, there is another function that we can use called set. So we're setting the initial values of our vector. And the first value is a random number based on point number, just like we did before. I'm going to rename our node create, color, and randomize. You always want to try and give your nodes meaningful names if you can. Although things like sphere and grid, I'm not sure I would ever rename those. I'll just leave them like they are. So in this one line of code, we're doing what these two nodes were doing before, okay? Now as a beginner, this might not make as much sense to you as what these two nodes are doing, which is why I recommend you use these nodes if you can, actually, because they're a little bit more intuitive than writing functions which you have no idea where they come from or what they are. But one thing I did want to just quickly show you here is if you're feeling a little bit confident and a little bit up to it, and you do happen to create an error with your function and you're not sure why it's working, what you can do is click over the blue part, the beginning part of the function, press F1, and that'll bring up the help for it. So you can find out what it's expecting, what it does, and exactly what values it's expecting, okay? The help is really useful. I encourage you to use it all the time. I'm using it every day, basically, and you'll become pretty reliant on it, just like Google. Another way you can bring up the help is by clicking on this question mark on any node. That'll bring up the help for this specific node. And then you can type in rand, and you'll see the first option will be the rand vex function. There are other random functions as well. I just thought I'd quickly show you this while we're doing it. There is a random vex function, which I think is the preferred function because it can do fancy stuff, but for this example it doesn't really matter. That's the basics of the attribute wrangle and attributes in general. Another thing that might confuse you when you're starting out and you're seeing all these, point wrangle, primitive wrangle, detail wrangle, they all actually have different names in the tab menu, so that confused me when I started. So if you type in wrangle, right, there's like 7 different wrangles, and that can be a little bit confusing, but I want you to understand that these all do the same thing. Except, if I type in wrangle again and I say grab a primitive wrangle, the only thing that's different is it's like the primitive here in that first what it's running over. So keep that in mind. They all do the same, and the same thing is with the VOPs, right? If I type in VOP, there's a ton of different VOPs that come up, but actually a bunch of these you can change between them to choose the different type of VOP. So they all kind of do the same thing. Strangely enough, except the volume VOP. The volume VOP is its own separate little guy. You'll see there's no option to change the type of thing you're iterating over in the volume VOP, but we'll leave that for now. Okay, I think that's enough of the basics of attributes. Attributes are super powerful, and it really is the core of how Houdini works. Your ants are always carrying little packets of something to their queen, right? And that is how the colony survives, okay? Because they're always carrying around stuff, and it can be absolutely anything. I hope I didn't lose you in that analogy, and we're going to continue on with the next node. So we've had a quick look at the attribute rename, the VOP, and this is why I added the copy, because we'll also tick that one off. The attribute wrangle, the attribute create. The attribute VOP we didn't quite look into too much yet. I'll cover that a bit more in a second. We did look at it as a way of remembering those global parameters. So that's a very handy trick that I want you to remember, okay? So next up we have the alembic. And also, because it's similar, we'll do the file. So let's have a quick look at them. The file node, you actually would have noticed at the start of the lesson. I'm going to hide this again. If I create any